3 to 5 minutes. Just going to give a few more people a chance to log on, and then we'll start the presentation. See you soon. All right, so we will get started. Thank you everyone for joining us. This is, I believe, our 10th Lunch and Learn. This one is just online version. Our last few were in person and online. So I'll introduce, if you haven't been to one of these before, I'll give you just a bit of an intro about myself. My name is Tyler. I work with Canada's Open Data Exchange. ODX is essentially a public-private partnership whose purpose is to help companies commercialize using open data. So we have partners such as D2L, University of Waterloo, OpenText, the Government of Canada, who give us funding, and then we're funded in kind by the government, essentially to help with economic development around open data. So a lot of our services are free. We help companies find and use data, and we help connect companies with various levels of government. On the flip side, we work with the government to help them build and form their open data policies and plans. We just finished a cross-country tour where we visited essentially all of the cities that are using open data and kind of asked questions and took in the general feel of open data across Canada. And we're releasing a cross-country report on the general state of open data in Canada in the next week or so. I believe we're hoping to have it out by the end of this week, so stay tuned for that. So without further ado, I'm going to pass it over to Steve Lang. He's going to be talking about Open Smart Cities data, and he is the founder and CEO of SensorUp. So take it away, Steve.
Sure. Thank you very much, Taylor. Let me share my screen. Okay, great. Oops. Okay. Okay, hello everybody. Thanks for coming for this webinar, and I'm going to talk about Open Smart Cities / IoT data. So today, my focus will be mainly on the IoT, Internet of Things. This is something I'm very passionate about, and I think it's also a very hot topic. So a little bit about myself. I'm the founder and CEO of SensorUp, but I'm also a full-time tenured professor at the University of Calgary in geomatics engineering. So for my research, I contribute a lot into international open standards. That means OGC, for example, that's the International Standard Organization for Geospatial Data, and United Nations ITUT working groups. So mainly focusing on IoT. I'm also active on some expert panels in Canada on greening Canada with ICT and the state of research and development in Canada. Okay, so just let you know that this is my passion to develop interoperable solution to connect different sensors together. And my approach is to use an open standard way. Okay, and the company actually is to implement the standard I developed using my research. So which is, I believe that my research is only a it's just a piece of paper, right? It's a standard, it's a piece of paper. But to show what's possible, we have to have the running code, the software system to show what's possible. So as a result, with my wife's blessing, I started my own company. It's called SensorUp. And SensorUp, we provide a IoT cloud platform, enable any organization to develop IoT applications or IoT/smart cities applications 10 times faster with open standards. And in addition, we enable instant on-demand integration of different IoT systems with open standards. The reason we can do this, integrate all the different sensing systems, no matter they are drones or a parking space or even a garbage can, connected garbage cans, is because we have this standard layer and to put them all together. And it's not, we didn't invent the standard. I mean, it's not a proprietary standard. This is an international open standard. So this is today's focus. And some of our users, we are a small company with about 10 people, but we have big users. So we have Homeland Security, Department of Homeland Security. They want to connect all the first responders, their sensors, and to save more lives. So we are working with them to enable that. We're working with Natural Resource Canada. And actually, I'm flying to Singapore. They are using our technology to build their smart cities. And similar in Taipei is going to establish a platform using our technology. So you must be curious right now, why these large organizations, they came to us, a small company in Calgary, and asked us to help them to build their smart city solution. And the reason why is really they don't want to be locked in by a big vendor, their proprietary solution. They want freedom and choices. So they want a solution which is an open ecosystem. This is the value we represent. The SensorUp believe in an open ecosystem for smart cities, especially for the IoT. So for those who are watching, yeah, so I want you to think about something right now, a physical thing. And the reason why I want you to think about thing is because I guarantee you, no matter what thing in your mind right now, they will be connected to internet. Some sensors will be embedded into that thing and transmit some data to the internet and into a cloud. And then somebody is going to use that information to make the life better, to make our city more efficient. So hopefully I'll give you some examples here. For example, there's a company, they connect drinks. How much water you are drinking, and then are you drinking a Pepsi or Coke, so that you know how to maintain your drink enough water, right? That's which is very important. Your baby, so this is a sensor, sparkling. It put on your baby, so know the baby's heart rate, heartbeat, noise in the nursery, as well as the temperature. And actually, I have a baby, right now it's 20 months old. And actually, I also put a lot of sensors on the baby, actually. I even enrolled my baby into a open IoT contest, actually. It's quite interesting. I won $200 US gift card, actually. It's quite interesting. So babies are very connected now. But let's talk about cities. So I was in a conference in Silicon Valley, and I saw this company. It's called the Victor Stanley. They make connected garbage cans. So their garbage can, they have sensors in the garbage can. They're able to detect, okay, how full is the garbage can? How heavy are the garbages? Okay, so so in this case, so what's the value? So the cities is able to always keep the street clean, while save the cost to clean them, right? Because you can do the minimum path and to collect only the garbage cans that are full or almost full. And you can also collect the pattern. So, okay, you can predict, okay, when the garbage cans will be full. Parking. So a lot of cities actually are sensor up their parking space, right? So try to put sensor to monitor the parking space. And then actually parking is a very interesting application. So the question is, why do we monitor parking? Yeah. So this is a good question. It's like, why do we put sensors for the cities? Yeah. So parking is interesting because actually parking is not really allow people to book parking space in advance. This is really bad actually, because that means only rich people and the people who have access the smartphone access can book the parking. And to censor the parking, to monitor the parking space is really about when you know the supply. So how much parking space is the supply? And then you can do on-demand pricing and to do the demand. You can control the demand. So it could become a closed loop system. And to optimize, okay, the parking space, the traffic pattern in your city. So this is one idea about really why you open up your or monitor your assets actually. Okay, so hopefully I give you enough example to show you that no matter how weird the thing actually, they will be connected to internet. And let's come back to what does it mean by a smart city. So the Wikipedia definition is a smart city is an urban development using ICT and Internet of Things. So basically it's put sensors, right, in the assets. So you can manage it better because you want to quantify. With sensors, you can quantify. Once you can quantify, and then you can optimize. So it's really about quantify and optimize, quantify and optimize. And today, actually, I really like this. This morning, I saw this definition from the mayor of Austin. I really like it. He said, a smart city to him is a city that has truly been able to look inside itself to identify what its challenges are. But the question is, how do you look inside itself? And in many cases is you use the sensors, like the parking, the garbage, your light, your air quality, your water level, your wind speed, and then you can really see what the challenges are, like air quality or traffic or it's a waste, right? And then once you can quantify, because you can look inside yourself, and then you can uniquely craft solutions to enable city to deal with these challenges. And by the way, because once you have the sensors, you can see immediately you will measure your solution, how effective is your solution immediately, because you get this feedback right away. So I really like this definition actually. And recently, I'm amazed by the airport, actually. The airport is very progressive because it's like a small city. It's very complicated. And right now, we know people travel with air and more frequently. So airport actually is a good example of a smart city, actually. And then from an RFP of a new airport in Taipei, new terminal, actually, their idea is they want to put sensors as most of places, for example, like the buildings, like the building management system, give the fire equipment failure status, the weather information, and then the tracking information for all the assets in the airport, and also the passenger information. And everything come together into a coherent system so that they can run this airport very, very smoothly. And time is very important here because the throughput in an airport is very, very high. So the room for failure is very, very minimum. So it's very interesting, actually. So, but they are progressive in a way. They really looking into the different systems into one coherent system. So building is not a silo system. The weather is not a silo system. The passenger information is not silo system. They want to see them all together as a coherent system and able to share the information in real time. And our cities, actually, if you look at our infrastructure, we are still far behind. But this is really where the city is going, heading to. So that bring us to this conclusion, actually. It's a very important concept. It's the real potential for Internet of Things. So, or we can say this, in order to unleash the potential for Internet of Things or smart cities, we really need to create a network effect. That means we want to treat the systems into as a coherent system, so that the information among different systems can be freely flow through, and then you can share with each other, and rather than just individual silos. Today's IoT or smart cities are like silos. Each one of them they built for their own purpose, and then it's difficult to share the information. And actually for this crowd, for us, we know it very well. Actually, it's about open data vision, right? So it's not, actually, it's how the information can flow and how to make it open. So this is really where the smart cities, they should go, the vision, the direction they should head to. Actually, some cities, they already felt the pain already. I talked to the CIO, CTO in Taipei a while ago, a couple weeks ago. Actually, I told them, do you know that in your city, you have about 1,000 air quality sensors? It's amazing, actually, and from different vendors, right? They do it for free for Taipei. It's amazing. However, do you know how difficult it is to put this information together? Because in a very short amount of time, in a year, they have 5 different APIs. And even for time, they have 2 different formats. So that means if you want to put it, you simply want to put a map of all the air quality sensors in Taipei, you are dealing with 5 APIs. And I heard it's a 6th API is coming up. It's crazy, actually. So I told you, I share with you, actually, I really love this garbage can. And then, so when I saw this garbage can, Victor Stanley, on your left-hand side, and then I was like, whoa, this is amazing, because it's a traditional, they have been making garbage can for 50 years, and they are putting sensors, making high-tech, right? I love this kind of story. And on your right-hand side is a new tech, like high-tech company, right? Like startup company. They make a high-tech garbage can called Big Belly. So I was like, huh. So let's say, okay, imagine, let's say your city. How many garbage cans vendors your cities are using? I don't think it's only one. Must be more than one. Okay, but however, in order to manage your asset, are you going to, do you want one system to able to see all the garbage cans and how full they are? Or let's say you have 5 different vendors, and then you can log into 5 different portals, and then just to take a look how full they are. So right now the situation is you have to go to their portal and then to look at how full they are and use their systems, right, to do the routing, this and that. And this is a silo system rather than a system of systems. So it's creating a lot of problems right now. So if you look at in more details, right, in a using technology, technical architecture, IoT actually are 3 things, 3 steps. The first step is collect. The second step is connect. The third step is compute. And so collect, connect, compute. So the collect means what sensor you'll be using. Connect means what network you'll be using. And third one is compute, means in what cloud you are going to store and analyze the data. So when you build your smart cities or IoT, think about it, 3 steps, 3 C's. And then for the third step, in one of the layer, and one of the critical layer is a cloud API, a cloud platform to manage the data and to do some analysis. And then there is an open standard for this. So this is the focus of today's presentation is, first I introduce you, use open standard, right? And to connect different systems. And second one is which standard actually is out there. So this is the OGC SensorThings API. It's a standard for the IoT/Smart Cities Cloud API. It allows you to interconnect different systems very, very easily. So there's a standard there. So if there's a standard, don't reinvent your wheel, yeah? So where does the standard fit? So if you look at even deeper in the architecture, so if you want to do a smart cities/IoT applications, here are the steps you need to go through from 1 to 7. The first one is to choose a sensor. The second one is choose a gateway, so you can put the sensor, plug a sensor into gateway and put that for your assets, right? For example, like a garbage can or a parking, yeah? And then third is you need to choose a network. In many people, they are thinking IoT, they're still thinking about network perspective. And there's a war on the network protocols over there. So you choose your network, but eventually it will go to the internet, right? Internet is the standard way to exchange information over the network, right? So eventually hit the network. But once you hit the network, you shouldn't stop there. you need to find a cloud solution to do that. And there are many different cloud solutions. However, there's an open standard based, so like OGC and ISO. And then that's where the SensorThings standard fit, is the cloud standard, provide a data model and the API, so that's the web service interfaces, allow you to connect the sensors to the applications. And finally, if you want to do a dashboard, a application, or do any analytics, and then that's a 7th step. So if you are using a standard-based solution, and then the 7th step, you can just simply connect to the standard, and then voila. You can connect to many different sensors networks or the assets without worrying the details, like which network they are using, LoRa, Sigfox, or NB-IoT, so on and so forth, because you deal with the information rather than the bits and bytes. Yeah. And when you are looking for a open standard-based solution, try to find a sticker. So a sticker, that means it's certified by the standard organization. So rather than the vendor, they self-claim they are the standard solution. Okay, find a sticker. That's very important. For example, all your web browsers, they are certified by W3C, for example. So when you're looking for a SensorThings API solution, find the OGC compliant solution. And here are some benefits of using an open standard basis solution. And for example, when you do your IoT, contextual information and semantics are critical, actually. Let's say you want to measure air quality. But actually, what does it mean by air quality? What are the units of air quality? The location of the important for the accuracy, for scientific reasons, and then the time format. And then these are all important. So by using open standard, like our model is ISO 19156, we took care of it for you. So the model actually provides you and asks you to put all the contextual information and define the semantics so that you can exchange your information with others, and then there's no missing information, right? So do not so reuse this standard is a good way to go. And also, using open standard can reduce your development time by 10 times, at least 10 times, right? Because you can leverage the existing R&D effort. And you can also, because it's an open standard, so there will be a lot of libraries, SDKs, open source, closed source, or hybrid solutions and documentations. It's an open ecosystem. So no matter what kind of solution you want to look for, and you can find one. If you stick with a vendor-specific a solution, and you are stuck, right? You can only use the vendor solution. So again, it's the preach, right? So use the open standard-based solution. Use a open ecosystem rather than closed one. So this is one example. When you have an open ecosystem and you have different libraries you can use, you can really reduce your development time. And on the screen, actually, we are showing you a no-coding dashboard. And using open source components, you can just put them together, and then it can change to different systems as long as they are compliant to the open standards. So this is really help you to develop your solution in an open way and also fast and cheap. And also, when you have an open ecosystem, you have a much better training and support from multiple sources, right? The highest quality. And then also documentations will be great because, for example, where do you learn the web, HTML and HTTP? A lot of places, because this is not from one vendor, but this is an open standard, for example. Okay, so right now, I think I push very hard on our standard, but because it's very good. So I'm going to show you some user stories. So who are using these standards to build their smart city solutions? So the first one actually is the Homeland Security. They want to connect their next generation first responder with the open standard, and so that in the emergency operating center, they can look at all the sensor information in one coherent picture rather than like multiple screens. Let's look at this firefighter, yeah? So in the future firefighter, at least one firefighter will have 4 different systems, like the smart shirt with the heartbeat, and the location, acceleration, and the heading, so where the firefighter is looking at, And there will be wearable camera so that other people can see what the firefighter is looking at, and equipment status, for example, how much oxygen left. And guess what? Are the firefighters going to use one vendor for all the systems, or there will be different vendors for oxygen tank and for the smart shirt? There will be different vendors. However, from a saving lives perspective, what they are looking for is one coherent picture to get all the information into one system, right? So as a result, DHS, Homeland Security, is really looking to open standard way to put them all together. So last year, actually, we've been to Washington, D.C. a lot and show a lot of demos. And we also been to Capitol Hill, actually, the Congress, and to show the system is really working. And this is quite interesting because as a techie, we cannot say, we cannot very often to say we save lives, right? But in this case, actually, we do save lives. And we also, when we talk to a lot of people, we found out actually there's one challenge is they found, okay, smart city solutions is expensive, right? When they talk to big vendors. And then we decide, you know what, it shouldn't be expensive. And then so we decide to do something, it's called Smart Cities Starter Kit. And this is starter kit doing one specific application. However, every step or every part of the architecture is using open standards. So it's also a kit show you how to do a smart cities in an open standard way. And in this case, the application is air quality. And fortunately, and thanks to Natural Resource Canada, we got some support from NRCan and help us to expand to 10 more cities. And then we did the first one in Calgary. So we sent out the call. It said, okay, who want to join this effort? So we are calling Smart Citizens. And at the beginning, we thought nobody interested, right? It's very geeky, but we got overwhelming responses. So one weekend in October last year, 50 volunteers came to our office and put the sensor by themselves together, brought them home, and then overnight, we have one of the most dense and the best air quality monitoring network in North America. And with the fraction of the cost of the current existing solution. This is the spirit of smart cities and the IoT. Okay, and then we're expanding this work. So we have more complete. For example, on the screen is our own board right now. We call it Smart Citizen Board. So we're expanding and the Smart Cities starter kit right now. And we're expanding to 500 sensors across 10 different cities. And the first city, the second one we went to is St. Albert, actually just last Saturday. And then August 12th will be Edmonton, and so on and so forth. And so this is a picture of our just last weekend, yeah? So 25 citizens, they came. And the city of St. Albert, and actually they also joined the effort. And then we worked together and to have this wonderful citizen sensing workshop. And I want to show you some data. It's unfortunate right now in the BC, the province of British Columbia, and there is a wildfire. And then actually the sensor immediately pick up the signals. And the air quality in St. Albert right now is not very good, actually. For example, on your right-hand side, there's a sensor. Actually, the reading is risky. It's not just unhealthy, it's risky. And then, so it shows that the benefits of such a low-cost, a smart city solution, and then enabled by citizens. Actually, really, we can get some insights, right? So think about the smart city definition. So we're able to see the challenges of the city itself, right? So this sensing system is really able to see the challenges. So this, in this case, is air quality. Okay, and also with other, can connect other systems with the other projects, which connect to drones. So not only the in-situ sensor like air quality or water, and this is something that flies, right? That drone is also a sensing system. And actually we can demonstrate that we can put drone and then air quality and other information instantly together into one coherent picture. And also right now we're working with Taipei, for example. The city of Taipei has the vision. They want to build a platform for all the sensors in Taipei. So actually we're working with a partner in Taipei and to provide that cross-domain IoT platform so that different existing sensors as well as new sensors, and at the end, they can use one standard to share information with each other. And I'm flying to Singapore, actually. Singapore has the most ambitious smart city program. And then I'm flying to Singapore. Singapore, again, they want to build their system using an open standard architecture rather than a siloed solution. So we are helping them. And so this weekend, actually, they are going to have a hackathon. So more than 100 teams and 200 programmers, they will use our platform and to analyze and exchange sensor information in Singapore. And I'm really much looking forward to what's the end result of this. And again, this is it's quite an honor, so that they approached us, a small company in Calgary, but they want to use our solution to do this. So in summary, first one is do not build silos. When you do a smart cities IoT solution, do not build silos. Ask your vendors, do you conform to open standards, and what are they? And do you get the certification? And what is the data model? Is the data model ISO standard, right? Or because a lot of vendors tell you, oh, I use standard because I use the web. Okay, come on, don't, ask tough questions, right? So data models, APIs, every layer needs to be standard, okay? So the second is use open standards, and many benefits, right? So I said future-proof, the contextual information, the metadata, and then the semantics. They are all taken care of for you. And finally, is our company pitch. Is we do provide a solution that has been used by all over the world, and then allow you to do it 10 times faster with open standard. And thank you very much for the time. And I guess we might have some questions.
Yeah, so feel free to ask some questions if you have them in the YouTube chat, and we'd be happy to answer them. Both for SensorUp, for Steve, about a 30-second delay, so I'll give it a minute for people to get their questions in.
Sure. By the way, if you're interested, where am I? I'm hiding in a corner at a conference right now. I'm attending a conference in San Diego.
What's the conference that you're at, Steve?
It's a GIS conference, Geographical Information System. So I'm invited to talk about actually the standard. Guess what? Standard for smart cities. Yeah.
Nice.
I'm really evangelizing. I believe that we should build the smart cities with open ecosystem rather than silo ways.
Nice.
That's my mission. Yeah.
All right. So we've got two questions. One from Meluka. How do you get around municipal data licensing or proprietary data?
Okay. So first of all, we talk to the cities and then we follow what they suggest. Okay. So what we provide is the technology, and then we enable the accessibility of this data. In some cases, the data actually are not open. Then they should not be open. Like the Department of Homeland Security, like you don't, as a city, you don't want to open where are your firefighters and where are the policemen, right? In an emergency operation, you don't want, but you want to share this information in your emergency first responder group, okay? But you don't want to share with everybody. For example, in a terrorism event, right? You don't want to share this with terrorists, for example. So in this case, very different license, okay? Or there's no license in this case, it's proprietary. But in some cases, like air quality, it should be shared with everybody, right? Water level, it should be shared with everybody. So we consult them what license they like, and then they use, and then they, on top of our technology, they have this license. What we address is really the accessibility technology layer. And for the air quality, we use I think it's Creative Commons, so it's just the simple license. Next question.
Thank you. So the next question is from Joseph. Steve, could you walk through an example of standards all the way down to the stack?
Of course. Let me share my screen. I can give you a very long lecture on this, actually. Okay, let me share my screen with you. Okay, so on this architecture diagram, each layer has at least several standards. or actually you can slice them into different, even thinner slice, right? So for example, let's look at the first layer, sensor and actuator. And there are some standards like IEEE 1451 is one standard. So allow you to read the sensor and get the metadata out. And then connect to the gateway, there is some standards like OPC is one standard, or Modbus is the other standard, and very widely using in the farming equipment, right? And the cars, right? Modbus. And then OPC is in SCADA is very popular. But however, from 1 and 2 is quite messy. And on 2 itself is a gateway. So from 2 to 3, which is the network. And network, there are many different protocols. And actually, there's a reason there are many different protocols, because you have different challenges in the field. Different field challenges require different protocols. For example, some require long range, some require high bandwidth but low range. So it really depends on your field operation. So right now, the popular one for IoT include LoRa, Sigfox, and NB-IoT. And by these three protocols, NB-IoT, narrowband IoT, is the true standard. So LoRa is from a company called Semtech. Sigfox is from a company called Sigfox. Yeah, and narrowband IoT is the open standard from 3GPP. So right now we see the narrowband IoT has a quick adoptions. Of course, 3G, 4G. And then finally, you hit the internet. So this is not the other standard, network standard, but at the end, everything hit internet. And once you reach into the cloud, there are one standard actually closer to 3 and 4. It's called 1M2M. It's from a industrial consortium, but they are quite open. So they also work with standard organizations. So it's a true open standards. So connect the sensors into the cloud. And then OGC, and after 1M2M, there's some overlap between 1M and the OGC a little bit, and then but OGC standard, which is the data model and the API to share sensor information, sensor observations. So for that purpose, this is OGC is the standard for semantics, location, and sensor observations. So it's closer to the 7. So 1M is closer to the network, and then OGC is closer to SensorThings API. OGC SensorThings API is closer to the 7, closer to information, and closer to big data analytics, data integration, and information sharing. So if you are building a system, right, so from 1 to 7, actually OGC SensorThings API actually allow you to do that in 4 and 5, 6, actually, it's enough. If you want to do some more advanced control for the network, for example, time synchronization, how to control different lights, how they flash together, and that's 1M2M is something you can look at. So this is a very short introduction of the standard layers in IoT, and there are more actually, but this is it. Okay, I'm back.
Very interesting. So a last question from Tim K. He's wondering, is this real-time data?
It could be real-time, it could be historical. So the API itself, the standard itself, support real-time pushing. So actually the data pushed to you in near real-time. I wouldn't say real-time because there's no such thing called real-time, right? So the delay normally is within, it could be, depends on network, could be 10 milliseconds to 100 milliseconds, but it pushed the real-time data, near real-time data to you. So the standard itself automatically support that. You can also filter using the standard way to filter the information. So I only want to get the data when the temperature is more than 25 degrees. Or the standard even also support not only a complex event filtering. So send me notification when this police car entered this boundary, and then the police car is heading north. So it's a very complex query because we can assume the data is huge, so you cannot consume them at the same time. So the event filtering is quite important, and that's also has been considered by the standard. It's not approved yet. I have to say that part, event filtering, is still in the development, under development. But the sensor sharing, observation sharing, has been published, but the event filtering is coming up very soon.
Great. Thank you. So that's all the questions that are in the chat. If anyone has anything else, feel free to ask it. But I'm just going to switch screens. Just want to take this opportunity to thank Steve for presenting. It was a fantastic conversation, and it sounds like you could almost do another one just on standards.
Yes, I could.
So going forward, we've got another event coming up on July 26th. IBM is coming back, and they're talking about design thinking and how it applies to successful innovation. So last time we did IBM, we did an in-person session. We had about 60 people at the Data Hub in Waterloo. This time we're going to do in-person as well as a webinar. So if you are not in the Waterloo region, you can still tune in and see it online. And that's pretty much it. If you have any questions afterwards that you think of, feel free to reach out to us. We will send out a survey after this, just looking for feedback. It looks like we have one more question. So Nuluka, who owns collected data if you use a SensorUp solution?
We are solution providers, so it really depends on the user, right? So for this air quality, nobody owns data. Well, we own the data, but we make it open. For DHS, Department of Homeland Security, they own the data, of course. So it really depends on we provide the solution and give you the freedom and choices. You can decide who owns the data. So that's what we offer. The user decide, yeah? It's like you decide who owns the data.
Perfect. Thanks, Steve. And I hope to see everyone again in a couple weeks for the IBM presentation. Take care.
Thank you very much. Bye.